The first section of Chapter 11 is the Introduction to Solid Geometry. So by the end of this lesson, you should be able to classify three-dimensional figures according to their properties, and then also use nets and cross-sections to analyze 3D figures. So three-dimensional figures or solids can be made up of flat or curved surfaces. For the most part, what we're talking about will have flat surfaces, and each flat surface is called a face. So in our cube that we made today, it had 6 faces. An edge is the segment that is the intersection of 2 faces. So remember, we counted those. We had 1, 2, 3, 4 on top, 4 on bottom, and then the 4 on the sides. So we ended up with 12 of those. And a vertex is a point of the intersection of 3 or more faces. So we had 1, 2, 3, 4, 5, 6, 7, 8 of those in our cubes that we made today. And we can transfer that to other shapes. Prisms is basically what we made today, but we'll be talking about prisms, cylinders, pyramids, and cones. So a prism is formed by 2 parallel congruent polygonal faces called bases connected by faces that are parallelograms. So this is a triangular prism because it has 2 triangles as your bases and then rectangles that make the sides. Like a Kleenex box is an example of a rectangular prism. So it has 2 rectangles on top and bottom, and then a bunch of parallelograms around it. Where a cylinder is formed by 2 parallel congruent circular bases and a curved surface that connects the bases. So your bases are circles, and then instead of having parallelograms, it's just one big flat sheet that wraps itself all the way around. Pyramids and cones are very similar, except a pyramid has a polygonal base, so it has a triangle, a parallelogram, a quadrilateral, a pentagon, something like that, where a cone has a circular base. But both of these meet at a common vertex, so they point up. The first 2 days that we're going to talk about this, we're going to focus on prisms and cylinders, and then we'll put pyramids and cones together. So a cube is a prism with 6 square faces. Other prisms and pyramids are named for the shape of their bases. So a triangular prism has a triangle on the bottom. Rectangular prism has a rectangle. Pentagonal prism, you guessed it, has a pentagon. On and on. We can do this with as many of these bases as we want to, but that's how we name them. So classify the figure, name the vertices, edges, and bases. So the first thing I notice is that on the bottom there is a 5-sided figure, so it's a pentagon. And since it comes to a point, it's going to be a pyramid, comes to a vertex. So this is a pentagonal pyramid. And then we need to name vertices, edges, and bases. So let's name the base, that's the easiest part. So the base is pentagon A, B, C, D, E, all the way around. The edges are where they meet. So we have A to B, we have B to C, we have C to D, D to E, A to E, and then we have them going up to F. So A to F, B, F, C, F is hidden in the back, D, F, and then finally F, E. And then the vertices. Remember, that's where edges meet. So we have a couple. We have F, we have A, B, C, D, and E. So you'll have some more practice with naming these and then naming their different parts. A net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. So to identify a three-dimensional figure from a net, look at the number of faces and the shape of each face. So this first one has 6 faces. 1, 2, 3, 4, 5, 6. And this makes a cube. And the way you can think about this is if this lays flat and these two come up, they would make the sides. This one would come up and make the other side. This would make the third side, and this would make the top. So I can tell this by looking at the net because all of these are squares. They're all exactly the same. And because there's 6 of them, I know that it has to be something that has a square base and it has 6 faces, and that's a cube. Where this one is a little easier, you have this base of a triangle, and then these guys have to fold up. And they're all going to fold up and meet in the center, and that's going to create a vertex. So this is a triangular pyramid. Forms a point. Now this one's a little harder, but based on the shapes we know, it has a circular base. So if we go back to our shapes, there's only 2 with circular bases, a cylinder or a cone. So it doesn't look like we have something that wraps all the way around, so we have to have a cone here. And if this part touches this part here, like if we make this touch, this is eventually going to come to a nice pointy vertex in the center. Last thing, a cross-section is the intersection of a 3-dimensional figure and a plane. So describe the cross-section. So it's kind of like we sliced one of our solids up. So this right here, if we slice it right at the right time, we end up with just a point. That's our cross-section, just one point. Where this, our cross-section of this pentagonal pyramid, is just a pentagon. If we take a cone and you slice it right through there, you end up with a perfect triangle. No part of it is curved. And we're going to do more with this tomorrow and play with some Play-Doh and chop it up and see how we get different cross sections. So you should be able to classify 3-dimensional figures according to their properties, and then use nets and cross sections to analyze them. Make sure you write down any questions you have, and we can go over them together in class. Enjoy your night.